In this lecture, we're going to learn about constexpr functions. And these are functions that have the potential to be evaluated at compile time. If you know, in our C++ development workflow, we have what we call compile time and runtime. And compile time is when your application is being compiled by the compiler, and runtime starts the moment the user double clicks or runs your application through the terminal to make it do things. So runtime is when your application is running. And in modern C++ versions, we have the option to move some computations at compile time and save the users a few CPU cycles they spent running these computations, because the heavy duty will have been done at compile time. And we make our functions be evaluated at compile time by marking them as constexpr. Let's look at a simple example here. We have a function called getValue. It is going to return an integer, and it is taking in one integer as a parameter. And inside, you see that we are just taking 3 and multiplying by the parameter that we passed in here. But the key here is that this function is marked as constexpr. So this is going to tell the compiler, if possible, do evaluate this function at compile time. And if we go in main here, we have a call to this function here, which is going to pass in a for. The for here is known at compile time because it is a literal. So on this call here, we really have everything in place to make this function be evaluated at compile time. And the compiler is going to compute it and store the result of that in this variable here at compile time. And when this application is run, at runtime, the main function here is going to run, and we're going to use the result of this function. We're not going to call it. This is the meaning here. But a constexpr function doesn't always run at compile time. If some parameters or some local variables in the function can't be evaluated at compile time, the function is going to be evaluated at runtime. And if you go down here, you see that we have a runtime variable, which is this integer here. And we use that as an argument to our getValue function here. Because this b here is known at runtime, you see it is declared in the main function here, so it's going to be set up and initialized when our application runs. That's why it is a runtime variable. If we call our getValue function with our runtime variable, the function here is going to run at runtime. Unfortunately, I don't really have a way to prove these things to you, but constexpr and compile time computations are a really big thing in modern versions of C++. And I just wanted you to have a simple introduction to this. Right now, we're going to head over to Visual Studio Code and actually try to run this code here. Okay, here we are in our working folder. The current project is constexpr functions. We are going to grab our template files in here and put those in our current project. And we're going to open this in Visual Studio Code. Let's do that. We're going to open the folder and say constexpr functions here. And we are going to open up our main CPP file, clean it up a little bit. And we're going to set up our function here. We're going to say constexpr, and the function is going to return an integer, and it is going to be called getValue, and it is going to take some value as an input, and the parameter is going to be an integer. Let's say value. Why not? Can't type, can I? Okay, we're going to go in and say return 3 multiplied by value. I think we called this multiplier. Let's make it multiplier. Okay, we're going to return 3 times our multiplier here. But when we say constexpr here, this function has the potential to run at compile time. Okay, and if, for example, we go in main here and say int result, and we say equals, and we say getValue, and we pass in a for, the for here is a literal, so it is known at compile time. We know this is going to be a for even by looking at the code here. So the compiler is going to see this for and know it at compile time. So everything we need to carry out this call here is going to be known at compile time. So this function is going to be evaluated at compile time, and the result of the call is going to be stored in our application binary so that the application can use it right away without having to call this function at runtime. This is what we mean here. So if we go here and say stdc out and say result and compile this application, let's take out this left pane here. We're going to use GCC. First, let's bring up a terminal and build with GCC. You're going to see that the build is good because this is valid C++ code. We can clear, let's say clear properly and run rooster. We're going to see that the result is 12, and this is exactly what we expect. We have a compiled time literal here, and the result is being evaluated at compile time. The moment we have our application binary, this is going to be a binary representation of a 12 here, because the function has been evaluated at compile time. This is what we mean here, and we are able to do this because this function is marked constexpr. Constexpr doesn't mean that the function is going to be necessarily evaluated at compile time. It simply means that the function has the potential to be evaluated at compile time when all the parameters and local variables can be evaluated at compile time. If we have one thing that can be evaluated at compile time, the function is going to be evaluated at runtime. And let's show you an example of that. Let's comment out what we have here. And we are going to set up a new variable. We're going to say int some var. And we're going to, for example, make it a 5. And what we're going to do now, we're going to say int result equals get value. And we're not going to pass in a compile time literal like we did before. We're going to pass in a runtime variable, some var here. Okay, again, this is a runtime variable because it's going to be set up and initialized when we get to run this application. You notice this is done in the main function. So this is a runtime variable. I really hope this makes sense. So because we are using a runtime variable to call our function here, this call is going to be evaluated at runtime. If we print this out, we're going to see the same result, but the mechanics of how our application is evaluating this function is very different from what we saw on top here. This is being done at compile time because everything the function needs to do this at compile time is available when the application is being compiled. But what we do down here is done at runtime because we have a runtime variable used as an argument to call this function here. Let's try and build and see if this is valid C++ code. The build is good. We can clear and run rooster. And we're going to see that we're going to get a 15 because we are multiplying a runtime variable containing a 5 with a 3. So we're going to get a 15 here. But the main message is that a constexpr function has the potential to be evaluated at compile time. If it is possible to evaluate it at compile time, the computation will be carried out at compile time when the application is being compiled, and the result is going to be stored in the application binary and used directly when the application is running. This is really all we set out to do in this lecture, and I hope you have a better idea about constexpr functions. In the next lecture, we're going to see how we can guarantee that our functions be evaluated at compile time. Go ahead and finish up here and meet me there.